Hello and welcome to part 2 of our review of C++ fundamentals. This is Professor Otters, and in today's lesson we're going to go over language basics, input-output using IOStream, functions, selection statements, iteration statements, arrays, and strings. And if you want to follow along, I'm working from Appendix A in the textbook. Again, you don't need to have the textbook. I'm going to go over everything. However, if you wanted to read a little bit more deeply, or if you simply wanted to follow along, I wanted you to know that you can do that with Appendix A. So first things first, we have our boilerplate. We create our main function and return 0. We give it a return type of an integer. We include IOStream if we want to do input and output processing. We include string if we want to use anything from the string library. And we put ourselves in the proper namespace, and we do this so that we don't have to write std : cout and then something, something, something. And then every time we use something like that, we would need to put std in front of it to use input and output stream. So variables represent a memory location that contains a value of an indicated data type. So what that means is that when we want to store some data, we need to make room for it, right? We need to put it, we need to make room for it on the stack. And to do that, we need to know how much room we're going to need. And so when we create a variable, we give it a type. It could be of type Boolean, character, integer, double. There are more data types. However, these are the ones that we're going to use for the purposes of this class. You might use things like longs and some other, I think float's one of them. It should be on the next page of the appendix. Yeah, there's Boolean, character, short, unsigned short, float, signed character, integer, unsigned integer, double, unsigned character, long, unsigned long, long double. So there's a whole lot of data types, but like I said, for the purposes of this class, you're only going to be using these 4. Constants are like variables. However, unlike variables, these are immutable, so you can't change them. With variables, you can update the values, you can reassign things, but with constants, you cannot do that. You do not change these during the program execution. You indicate that you're going to be using a constant with the const keyword. So again, these have values that do not change, and the keyword const precedes the data type. Additionally, you will also want to create all capital, all uppercase for your variable name. And this is like an industry standard, but it's also a standard across many programming languages to do it this way. And that's so that if somebody else comes and looks at your code, they know, okay, it's all caps. That must mean it's a constant. That must mean I shouldn't do anything to it, and I'll leave it alone. So here's a simple program. Yeah, just go ahead and take a look at it. If there's anything that you don't understand, it will be explained in the next few slides. So enumerations are another way to name integer constants. The example here starts with enum as the keyword, and then sun, mon, tus, whens, days of the weeks. It's equivalent to the statements const int sun equals 0, constant mon equals 1. By default, values assigned to the enumerators begin with 0, and they're consecutive. So they go from 0 to however many. And you can also create a distinct integral type, like right here. And in this case, we created a distinct integral type with plus equaling the plus character and minus equaling the minus character. And this is, again, an assignment of these values. You can also name the enumeration. This one's named season. It's of type season now. The variable name here, season, indicates that we're going to have winter, spring, summer, and fall. And a lot of the time your variable names are going to be like this, indicative of what's being stored inside of them and how you're going to use them. Typedef statement may not be something that you've worked with very much, but it's a way to give another name to an existing data type. So in this way, you can make your program easier to modify and to read. So in this example, type def double real, we're saying type def double real. So real is going to be of type double. We are doing something called type aliasing, where we give another name to a type. And it's helpful because it allows you to increase the precision of your this one allows you to increase the precision of your computation without having to type out long double every single time. Your alias for that is called real. So over here we have const real pi. Real represents double in this immediate example. If it were this declaration, then it would mean long double in this for wherever we have the word real spelled exactly like that. Okay. We have expressions. You form an expression by combining variables, constants, operators, parentheses. So I have a statement here where we declare a double and we call it volume, and it's equal to the following expression. The right-hand side of the assignment operator, this is called the assignment operator here, is indicated as something that will be calculated during the runtime of the program. We also have relational and logical expressions. These are the relational expressions right here. The less than, greater than, less than or equal to, greater than or equal to, is not equal to, and is equal to. And I want you to remember that the double equal sign is when we evaluate something, and the when we're evaluating an expression. And the single equal sign is assignment, like it's used here. So one is for evaluation and the other is for assignment. So the two equal signs is for evaluation. The one equal sign is for assignment. And typically you would see parentheses with these, with an expression like this, and you use parentheses to specify precedence over another operation because C++ follows the order of operations. Arithmetic expressions follow the order of operations, just like just like in your algebra classes when you're doing your homework. You need to mind your parentheses, exponents, what else? Divisions, multiplications, additions, and subtractions. And you can do all of those things here. Finally, we have logical expressions, which are the two ampersands, which mean and the two pipe operators next to each other, which means or. So let's go to the next slide. So we have input using the IO stream, and this cin is as long as we've did using namespace std and we have hashtag include IOStream, we should be able to cin user information. So in this case, we are taking in a variable. This must be declared beforehand, so that's done off screen. But we are taking in whatever the user puts and storing it into the variable x. You can also do it this way, following this way or this way. And then finally, getLine is a way to get the whole line. So whereas cin will get whatever the user types up to a space, getLine will get the whole line, including spaces. So for example, if I wanted to get the title of a book, I might not use cin to do that because that's only going to give me one word up until a space. So if the book is called The Fox and the Hound, it'll only get the. And if I use getLine, then it will get the whole line, which will be the fox and the hound, and that would be effective that way. We also have output using IOStream, and this is similar, except I guess what these are called, they're like an output operator is pointing to the left. So it points to the left, and then you're able to write strings, and these are outputted to the console. You can output variables to the console. You need to be mindful of your spaces when you're trying to create something that is easy to read for your users. And then you have these manipulators. So this right here, this \n is called a manipulator. This one goes to a new line And then we also have a list of manipulators, including ones that you use often, like endl, and then some that you don't use very often, like scientific. I don't really use that one very often, but these are going to help you. Let me see if I could get rid of this really quick. Oops. I'm trying to get rid of what's in the back. Okay, maybe not to do that right now. Let's see, what slide are we on? Stream manipulators. Okay. And then next we have functions. A C++ program is a collection of functions. And a function is preceded by a return type, and then whatever you wanted to name the function, and then in parentheses, a list of the parameters that that function is going to use. You can have it return, you can have your function have a return type, or you can specify that it doesn't return anything. In that case, it's a void function. When you name your function, you want to make sure to name it descriptive of what that function is doing. And something that goes hand in hand with that is to make sure that your functions do one thing really well. And what I mean by that is that you have a function that has one well-defined task that it does, whether it's getting the sum of two numbers or it's getting the correct time. It does something, one thing, very well, and it doesn't do other things. You don't want functions that do a whole bunch of things and then to use that in your program, because that can become vague, and then your program can become hard to come back to, hard to interpret, hard to read, hard to debug, a whole bunch of stuff. So what you want to do is you want to make sure that your functions only do one thing and that they do that thing very well. You want to think of your program in terms of functions. So you want to like link up different functions together and have your functions cooperate together. And then standard functions would be something like square root, sqrt, the input function get that we saw in the previous example. So those are things that we import or include. And functions can be passed by reference or passed by value. And what that means is that we have a way to pass in a copy. In this example, this is passing by value. It's passing in a copy of the values of x and y, and it's returning something. It's returning x or y, depending on which is bigger. And then on the right, it's a pass by reference because we have the address of operator here. And so this means that we're going to edit the original value for larger. And this says void, but it is doing something. It's editing whatever the value of larger is and assigning it this conditional expression, the results of the conditional expression. And on that note, we have if statements. And if you recall, an if statement starts with the keyword if, and then in parentheses, you have some sort of expression to be evaluated. And then you have curly braces. In this example, you're going to notice that there aren't curly braces because technically if you're only having, if your code only has an if statement with no other conditions attached to it, then you don't need the curly braces. But I still recommend that you use them if you're going to have if else or if else if else if else or whatever else. You definitely need the curly braces. But this is a special case of when you don't need curly braces, this top example here. In the next example, if a greater than b, if this evaluates to true, so if a is bigger than b, then the code block directly underneath within the parentheses of the if is going to execute, not the else block. And likewise, if this is false, if a is not greater than b, well then what? Well, else the stuff in the code in the else code block will run. And it's not both of them run no matter what, it's one or the other. And then at the bottom, this is definitely going to run because it's not in any of the conditional blocks. So Okay, and then switch statements aren't really something that I use too often, but when you must choose among more than two courses of action, the if statement can become pretty unwieldy. So it might be a reason why we don't see it very often. But this is the form of the switch statement. This one's a little bit out of order. Normally they are consecutive numbers, case one, case two, case three, and you're used to seeing them like that. But this is a program, a short program that designates the month as an integer from 1 to 12. So in here would be a 1 to 12. And the Boolean leap year is true if the year is a leap year. And this is pretty much it. Oh, you need to have break statements to break out of the switch statement, and you also need a default statement. So if none of these cases happen, you must have a default, something that will execute in case none of these cases are triggered. So next, we are going to talk about iteration statements, and that's going to be your loops. So a loop is something that you use when you want to repeat code over and over and over again. It would be a totally bad use of your time to write the same code over and over and over again to get it to repeat. Instead, we have something called loops, and the for statement provides loops with the ability to go on for a designated amount of time. So when I know how many times I want my program to loop, I'm likely going to use a for loop. And with C++, you need to declare a variable that's going to become the iterator. The iterator will be evaluated. There's some condition where it's going to be evaluated, and then we're going to increment or we're going to decrement, depending on whether we have two pluses after the iterator or two minuses. And this is just a little program that outputs the number 1 up until n equal to n. We use while loops when we don't exactly know how many times we want to loop. We just know what condition we're going to stop at. So while loops, you still need to declare something that's going to be your iterator, a variable to be your iterator. You're going to need to create a condition for when you want the while loop to stop. You precede this condition with the keyword while, and then in curly braces, you write what you want to do. And you need to write this code, the body of the while loop, in such a way where the condition will eventually be met. Otherwise, you get an infinite loop and your program crashes or your computer gets stuck. And that's not good, unless, I don't know why you'd want that, but unless you want that. And then finally, do while loops are a loop that you know you want to execute at least once. So the body of the loop needs to execute at least once, and then it evaluates, okay, do we do this again? And this short example is while response is the character capital Y or response is the character lowercase y. And they take on this form. Arrays can be a little bit tricky. Getting through them can be kind of hard to do. In this example, we have a constant that's going to indicate how many items we want in the array. This is going to be of type double. An array is a container of items that have the same data type, and it's pretty useful if you have a collection of things that you want to store and that those things have an order. You see that we have an enumeration called day, and we're able to loop through our array using that enumeration. So that's something that we talked about a little bit before. Once again, this time using typedef, we create an array that's of size 7 days per week. It has a constant. And then here's an assignment of an array. You use curly braces. You add a semicolon at the end. You make sure that the data type matches the data type at the beginning of the line. And then here is a short diagram of what this looks like on like as a space that's being populated. Arrays are always passed by reference in functions. So when you pass an array to a function, you will always be passing by reference. And then here are a couple ways to declare them. In this example, double temperatures with the curly braces, and then you pass an int n because we need to pass in what size the elements in a one-dimensional array are gonna have. Or rather the amount of items that the array can hold. Two-dimensional arrays are arrays that specify a number of rows and a number of columns. And here's a picture of a two-dimensional array. You're going to be working with these a little bit more in this class. And then here's an example of an array called X of type integer with 2 rows and 3 columns. And then here's the curly braces are going to designate it as 2 rows and 3 columns. Finally, we will talk briefly about strings. Strings are just text. They're like a text variable, and you can initialize an empty string. You can initialize a string literal. You can reassign strings. You can perform functions on them to get the amount of characters that are in the string, the size of the data type. You can get a single character from the string if you index the name of the string with an index that you want to receive. And then here are some here's some little functions. You can use substring to get characters from 2 to 7. And then here are some here are the orderings of strings as they relate to evaluation expressions, and how some of these, according to the ASCII table, have precedence over others. And so, yeah, that's pretty much it. So I hope that this video lesson was helpful. If you have any questions about any of these things, please feel free to email me. I will get back to you as soon as possible, likely within 24 hours, unless you're buried in my inbox, which is why I promote the use of Canvas inbox, because I will likely see it there. It won't get buried. But thank you so much for listening. Have a wonderful day.